Hi, welcome back to CMG-MathSpace. We are stepping boldly into the math space. If you remember, we were talking about how to represent the properties of sets in a Venn diagram. We did a conceptual video giving you the guidelines or the outlines. Conceptual one, giving you the theoretical aspect of this property. We gave you some rules like whenever you are given a set problem to be represented in the Venn diagram, the steps that you have to take. You don't have to rush, read them out literally, and then when you are given, you start with the grouping, the union, intersection, and then complement. This is the order of precedence, right? But when they are given in a plane without any intersection, union, or complements, you just have to go straight and do the shading. Right, now this is going to be in series because I don't want to be bombarding you with these properties or how to shade them, else you get confused. So I'm going to start with the basics, with the normal sets, the intersection, then the union, then we go into complements, and then finally the union and the intersection, the shading procedure. So stay tuned. Now let's start here. You can see on the screen we have set properties. The properties we talking about when we have a Venn diagram, we have the union sets. That's where we talk about everything, right? We talk about everything in the sets, and then we are represented it as what? The background or the universal set. So if you can see on the screen, we have the blue area of this rectangular shape, right? That is the universal set. Everything that we are talking about with the various sets, the complement, the union, everything, right? So that's the mother set. And then when we move on into what? Complements, and then finally into the other properties, right? So let me be swapping between these two screens. So here, for the basics, we have the U. The U is the universal set or the rectangular what shape. So in this particular first top left shape, you have the white background, and that is the universal set represented with the symbol U, or denoted with the symbol U. Now we come to A. The A is the whole of the yellowish area, right? You can see a part of it is being covered in B, and we have a section like an intersection overlapping, right? So when you are considering only A, sorry, not only A, you are considering A. Now the terms are going to be, if you don't take care, even with my explanation, if I don't think I'll be confusing you with the terms, so I'm going to stick to this. So you have the A, that's A, everything in A, that is it. Then we have the B. So A is the whole of the what? The yellowish area. Now the same thing is applicable to B when we are only talking about B, right? So the A is the shaded area. Then when it comes down, we have B is a proper set or the proper subset of A, meaning B is found in A. It's a subset. That is it. Then let's move to the third item. We have U, and then we have A, the whole of the white area, and then we have B, the whole of the circle, and then a part of the white. Now we'll talk about A complement. Now let's go to A, the other screen, and talk about the complement. Now we have definition. The universal set is blah blah blah. Now I'll come down to definition again. A complement of a set is everything that is not in A. Everything that is not in A. So still looking at the diagram there, we have that. Then the notation. The complement of set A is written. We have these symbols A, superset or superscript, C, A apostrophe called the complement, or we have A, the dash at the top. So that is it. So we have, if you see the U there, U has 1, 2, 3, 4, 5. That is it. Then A, talking about A, you have 2 and 5. Then A complement will be 1, 3, 5. So that is represented in the diagram. It's as simple as that. Please take note of these things. When you start to build up the blocks, don't get confused. So stick to this. Yeah, it's as simple as that. These are the basics, right? So that is it. So looking for A complement, you see 1, 3, 4. So that is the area of the complement. This is different from A only. This is different from A only. And we have A. We have A only, we have A, and we have A complement. So A here is 2, 5. Right? Now, when we combine with other properties like B, other sets like B, C, then we will talk about the A only and then B only. So here, we are only seeing A and then A complement. There's no A only here. You only find this. You only find this when it's being combined or joined with other sets. So take note. So back to the screen. So now you see A, the complement, then A and B, the disjoints, right? They are not intersecting, no union, whatever, whatsoever. Then we have down, we have from the B being a proper set of A, the next one will be the A and B. We are looking for the intersection. The intersection is the shaded area in blue color? Sorry, in yellow color. So both A and B. So A intersects B, and the symbol is A intersection B. That's the N symbol. So when we move to the last diagram, we have either A or B, or another expression A union B. Then the final notation is A U B. Right? So you see the difference. So the shaded area are the green that we are talking about. Sorry, why am I mixing the colors? It's the yellow that we are talking about. So take this very carefully. Take them seriously, because we are going to build on this. These are the basics. So we have covered properties of the complement, and then we have covered the individual ones, the normal one, the A, B, and the union and intersection. So stay tuned once we tackle the other properties. We see you soon. Please like, share, and subscribe. Bye for now.